All right, let's continue our conversation on the place value system. Last time we were together, we chatted about the place value, the number system, as well as comparing numbers. Today, we're going to reshape our conversation. We're going to talk about rounding and estimating numbers. After this lesson, you should be able to round numbers to any place, which would include both whole numbers and decimals, and estimate sums, differences, and products. And really, the rhythm of kind of where we're going here is that the first thing you're going to learn to do is round, and then I'm going to show you how to take that skill and kind of really apply it to more real world um, scenarios by estimating. So we'll round first, and then we'll jump into estimating, which is really just an application of your ability to round numbers. So we'll take a look and we'll begin with rounding. I realize that this is something that you've probably been learning for the past 3 or 4 years mathematically, so nothing really new today. Just honestly, let me show you my way to do it, and then more importantly, I want to show you how to show your understanding with it. And so we'll look at both whole numbers and decimals. Remember that our learning targets, we can do it to any place. So the first thing you need, we just need a number. And let's start out with something kind of easy. We'll take number 326. And if I were to ask you to round that to the nearest 100. So the first thing I want you to do, and I'm going to change up colors just for visual here, but I'm going to say, well, what place was I asked to round to? And that's my hundreds place. I want to round right here to my hundreds. So I want to know essentially what 326, if I were to have, and just again to give you kind of a visual here, is let's say here is my number line. This is 300. This is 400. What rounding is really asking is which of the hundreds are you closer to? It's 326 would approximately fall right about there. And we know that it's closer to 300 than it is over here to 400. And that's a way that I can show you. So this picture helps me understand this is why. But from a mathematical perspective, what does it look like just to look at the number? So the reason I draw the number line, I show the picture, it's a way for you to kind of visualize what exactly are we talking about. Is we're given a number, and when we give that place, we're kind of saying, hey, which one are you closer to? So what I do here is I look at my hundreds place and I'm going to underline it. And then I'm going to go one place to the right, which from the hundreds is the tens place. And what the tens place does is it's going to inform us which way do we go. Now, many of you probably heard several variations of little ditties, such as four or less, let it rest, five or more, add one more. And so that's kind of what we're looking at is when we go next door, we're going to look at the two here. And the two, because if it is four or less, we are just ignore, right? We are going to ignore and not do anything to it. If the number was five or more, then we're going to add one more to this number. So for this particular problem, we would round 326. We would round it to, we're going to leave the 3 the same. And what we're essentially doing is every place value to the right of the number it wants us to round it to, we are going to turn it into zeros. So we don't change the number of place values, and 326 rounded to the nearest 100 would be 300. Why? Because look up here on my place value, or on my number line. 326 is closer to 300. And even looking at that particular scenario here, I know that any number from 349, every number from 350 would round to 400 because it's closer to. That's really that breaking point, and that's why at 5 or more, add one more. I would have added one to my 3, and that would have made it 400. So that's kind of a look at the basic look at round decimals real quick. What if I had the number 3 and 56 hundredths? And I'm asking, we're going to round this to the nearest tenth. Now remember, look at the details. When we start dealing with whole numbers and decimals kind of together, make sure that you're really looking at what is it asking you to round it to. In this particular problem, It is asking me to round it to the nearest tenth. Again, I'm going to put my yellow on to show you kind of what you should be writing. Um, and so I'm going to underline where I mean, this is good student practice here when you're dealing with these numbers. It also, on a short answer scenario or anytime you're asked to show your understanding, this is a great way to say, hey, um, this is not only the strategy, but it's a strategy that helps me show my understanding. So my step one is I am going to underline I'm going to run out of space here. I'm going to underline the place. I'm going to call it the place position. And I'm talking about this. Okay. I'm going to underline it. That's my first step is kind of write my number down, underline what I'm rounding to. At that point, you are going to draw an arrow to the place. Let's do this. You're listening and watching, so we're on the same page. I'm using PV, place value. That's what that means there. We're going to draw an arrow to the place value to the right. Okay, watch. Just one place over, not two, not three, just one place over. Now at that point, what is essentially happening when I do that, imagine I take a sword and I'm cutting that off. Okay? And so before 6 falls away, he is going to yell something at 5. And we know, regardless of the scenario, that dropping in here is a 0. So a 0 is going to take his place, but before he falls away, he's got some last words for the 5. Now go back to what we talked about. We had a rule. Any number 0 to 4, same, right? Nothing changes. 5 to 9, add one more. And that's what he's telling him. He's either going to say stay the same or add one more. Well, because the 6 falls in this category, he's going to tell the 6 to, or the 5, I'm sorry, to add one more. So 3 and 5600 rounded to the nearest tenth would be 3 and 6 tenths. Because the 6, as it fell away, he said, hey, add one more. Now, I know I said here, I said, well, there's a 0 being added there. I think there was a 0, right? I know that this here has a 0. In fact, I can put as many zeros here as we want. One of the numbers, and when we talked about this when we ordered, I called them dead zeros. Again, that's not a mathematical term. It's just something that you'll hear me use. But I just don't show that because this here is kind of the cleaner version of the number. I want this. But do these guys change the value? Think about that for a second. If I add a 0, does it change the value? If we're in class right now, it'd be a great opportunity for me to have you talk to your shoulder partner, but can't do it right now. But just think. Are those equal? And the answer is yes, because there's no value to this number, right? It's 0. There's no value, so I didn't add, by adding a 0, I didn't add any value. I didn't change. So these two values are equal. It's simply represented differently. So long story short is you can think about the 0 coming in because I think that'll really help you with whole numbers. Because it is important that we have to put whole numbers and replace the whole numbers with zeros. Otherwise, we change that value. But at the end of the day, the big thing you want to really do is, go to the place it's asking for. And let me finish our list here. So we do this first. I'm going to underline it. Then I'm going to draw an arrow. And then the third thing, I'm going to refer to we'll call them the rules of rounding, which are these guys. So you should know those. 0 to 4 is going to stay the same. 5 to 9, we're going to add one more to that underlined place. Those are 3 quick steps on how to round. But now let's transition into what we call estimating. So when we look at estimating, one of the things that we're going to do is we are going to look at estimating from three mathematical perspectives. We're going to talk about sums, which is addition. We are going to talk about differences. Just subtraction. And we are going to talk about products, which is multiplication. Let me take a quick, let me get off the road for a minute and just chat with you real quick about these three terms. And I'll throw quotients in there as well. I cannot stress the importance that you know proper mathematical terms. As you grow older in your understanding of mathematics, those basic terminologies like adding, subtracting, multiplying, they begin to evolve. And you start to hear a little more polished language, such as sum, different, product, quotient. And particularly this year, I really stress it. I mean, if we're going to be intellectual mathematicians, I want you to speak intellectually about mathematics. And so, if these, when you see them, make you stop and go, oh, what's it talking about? Just get comfortable using them, because I think that's, again, it sells you as a mathematician. So when I talk about estimating sums, differences, and products, let me just show you. And I'm going to group these two together, and then I'll talk about this one on its own. So when it comes to sums and differences, one of the things, and I'm going to tell you the kind of how to, and I'm going to tell you the why, is what if I had this number right here? And I said, okay, quickly, what's the answer? And clearly, that is not friendly mental math. Well, with our estimating, what estimating is really, we're looking at mental math. We're looking at, can you look at a scenario, whether it's through addition, subtraction, or multiplication, and can you quickly generate an estimate? And one of the things you're going to hear when we talk about estimates is there is a word that's attached to it. It's going to say, hey, about how much. For example, let's just say hypothetically that I have 3,267 baseball cards, and my son Hagen has 1,475 baseball cards. And I said, well, about how many more baseball cards do I have than my son Hagen? Now, when I say about, I just want a ballpark figure. Well, about how quickly, and we're looking at mental math. So what I'm going to do is I'm going to bring the rounding in, and I need to kind of think through, what would it be wise to round these two numbers to? Now, I could quickly go to thousands, right? I could say, well, this is 3,000. Do you see how I did that? I went here, next door, 2 tells me to stay the same. And I could come here, go next door, 4 tells me to stay the same. And I've got 3,000 minus 1,000, and quickly you can spit out he's got about 2,000 more cards. Now, likewise, I could have also gone to the hundreds place. I could have gone and said, well, roughly 3,300, because my 2 went next door to my 6, it told it to add one more, minus 1,500, and that's roughly, the difference in those two is roughly 1,800, which again, these are both estimates. I just got close with it. But what estimating is you're looking at, when you deal with sums and differences, you want to round it to a specific place value. Typically, it's going to be a larger place value. It would have done me no good to round this number to the nearest tens. Typically, it's going to be one of the 2 larger place values. In this one, I would say this would have been the more fruitful venture. It's much easier mathematically. Even me, I had to stop and kind of go, okay, 3,300 and 1,500. Now, quickly, I double 1,500 to get to 3,000. So there's 1,500 plus 300, and then I got my 1,800. But it was mental math. But the most friendly was 3,000 minus 1,000, about 2,000. And it got me close. And so that's when we talk about estimating, that's what we're doing. And then you're going to see another one with products. Same kind of thing, it's just a little differently. What if I have the number 1,477 times 3? Now with estimating products, you only have to round the first one. Okay, so what you're going to do is you're simply going to look at this number and round it. Now to get closer, that again, this is, ballpark, you could do about the same thing. And a lot of times in a mathematical scenario, it's maybe going to give it to you. So it may say, hey, round this to the nearest thousand and estimate, or round it to the nearest hundred. So here, I'm going to round this number to the nearest hundred. I'll go to my 4, go next door. The 7 tells that 4 to go to 15. I know that's about 1500 times 3. You don't do anything to that number. Leave it alone. It'll be a single digit at your level right now. If it gets bigger, then we can worry about it. But for right now, as we learn this skill, leave it alone. Now here, the mental math here is I'm going to go 15 times 3 is 45, and I'm going to bring those 2 zeros down and say 15 times 3 is, or 1,500 times 3 is 4,500. Ballpark, it's close. Get your calculator out and punch that in, 1477 times 3, and you're going to be within 100 of the answer. It's just over 4,400. So that's what estimating is. So estimating is where we roll our skill to round into a real world scenario, and um, it'll let you do some mental math to kind of get about where. A lot of times, and probably your parents would vouch for this, and this is money for a lot of people in terms of when you go into a store and you see something that's $27.99. I mean, just as you start to add up how much things cost, you're going to look at that item. Well, okay, that's about $30. Well, did it cost $30? No, it was about $30. And so as you start to add up, a lot of times when we shop, we estimate. And then we get to the cash register, and we typically, the actual cost is much less than the estimated cost, because we were constantly rounding up or rounding, just a little bit down, and it all kind of washes itself out. But that's where estimating really washes into the real world. So this is a look at rounding and estimating. So after this lesson, you should have a just a basic understanding of um, rounding numbers to any place value, and then being able to roll that into estimating sums, differences, and products. From here, you'll take this and do some practice work, and in that practice work, definitely make sure you're thinking through not just what the right answer is, but why is that the right answer, because in mathematics, that is always the most important part. It's not about only about right answers, it's also about understanding why that is the right answer. That's all I got for you today. Till next time, have fun mathing. Later.